As it has arisen, life on Earth is inevitably destined to end. The first life forms to disappear will be the complex ones, such as human beings. And only later will it be the turn of the simple ones. The fate of the planet is also already sealed, intimately connected to the life cycle of the Sun, which is halfway through its journey. The spark of life was ignited billions of years ago on Earth, perhaps triggered by the impact of meteorites or comets capable of feeding the primordial soup from which everything began. Whatever process made Earth the only planet known to us with an extraordinary biosphere, it is good to know that this inevitable privilege will not last forever. Life is doomed to an inevitable end, just as the fate of the globe is sealed. Of course, these are very long times and intimately connected to astronomical phenomena, which have nothing to do with the ephemeral duration of individual human life. What is certain is that the Earth in the distant future will no longer be the green and blue paradise we know today. But will most likely turn into an alien, hot, and totally inhospitable world, like the planet Venus. How long will planet Earth exist? How long will the human species survive? It might seem like a single question, but in fact, it is not. In fact, the fate of our planet follows an entirely different path from that of our species. The two events, in short, may not be linked. Let's see why. One might think that our civilization will die only when the Earth dies. That is when our planet can no longer ensure the minimum environmental conditions for the survival of the ecosystem. If that were indeed the case, then how much time do we have left? Answering that is not easy. But let's put it in this way. If in the next billion years our planet has not already been decimated by nuclear wars or by sudden cosmic apocalypses of another nature, such as a bombardment of asteroids and comets, the explosion of a very nearby supernova, or the passage of a passing star into the solar system, well, then it will surely be the Sun that will put an end to the habitability of our planet. How do we know? There are but two ways to understand what will be the fate of our Sun and thus that of the entire solar system. The first is observational. Our near universe is full of suns, each caught at a different time in their existence, and patient data collection has enabled generations of astronomers to put together a coherent theory of stellar evolution. The future of our Sun then is in this way revealed to us by stars that are at a more advanced stage of evolution. The second is the theoretical one. A physical mathematical model is set up that succeeds in describing the Sun's operation in the present, then harnesses the computational power of computers to observe how the system evolves by introducing the time variable. In both cases, which obviously condition each other, this is not a simple procedure. Our Sun, like all stars, is an extremely complex system, and to describe it accurately, it is essential to bring together cognitions of chemistry, gravitation, thermodynamics, quantum mechanics, and nuclear physics. Well, thanks to all this, we now know that the Sun is a very quiet, small to medium-sized star. So much so that it falls under the definition of a yellow dwarf. A star that, like all its small mass companions, during the main phase of its life, sustains itself and emits energy through nuclear fusion in its central region. Many hydrogen atoms are fused 4x4, producing helium nuclei and additional energy. In this way, what is called hydrostatic equilibrium is achieved in the star. In practice, the radiated energy which pushes outward from the core succeeds in perfectly balancing the enormous pressure of the overlying matter, which, driven by the force of gravity, would tend to plummet towards the core. The star spends the majority of its life in this balanced state, although sometimes some stars go through more or less severe phases of instability. Hang on a sec, guys, before we continue, be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. After 6 or 7 billion years, however, a star like our Sun begins to run out of hydrogen in its core. This moment marks the beginning of its old age and the end of a relatively quiet life. The balance that had so far sustained the star fails, and it must undergo a series of violent changes. The star is now rich in helium and poor in hydrogen. Nuclear fusion reactions slow down for lack of fuel, and the star can no longer support its own weight. Its core then begins to contract, and in this way its temperature rises. The region surrounding the core also heats up, and the nuclear reactions that have died out in the core reignite in the peripheral layers. To dissipate the heat produced by the new reactions, the outer layers begin to expand and cool. The star thus enters the so-called red giant phase. The Sun will expand to about 250 times its current diameter. In this phase, the Sun will lose some of its mass and thus diminish its pull on the Earth, which as a result will move away, describing a wider orbit, but this will not be enough to save our planet. In fact, already at this stage, the outermost part of the solar atmosphere will reach our planet, and although very faint and almost imperceptible, it will be enough, due to the enormous heat, to evaporate the oceans and generate gigantic fires all over Earth. In practice, our planet will already cease to be habitable in 2 to 3 billion years, depending on whether one gives credence to the most pessimistic or the most optimistic estimates. In that time, however, the rocky trans-Neptunian dwarf planets such as Pluto, Eris, Makemake, Haumea, Sedna, Orcus, Varuna, etc. will warm up, reaching temperatures similar to those on Earth today, and could provide a temporary refuge for humanity, if it still exists at that time. Of course, the immense problem of relocating billions of individuals remains, but the slow pace at which these catastrophes will manifest will give us a way to deal with the problem in time. All is well then? Will we be able to get away with it even in this distant future? No, it seems not. In fact, some say that here on Earth we will begin to fare badly long before the Sun's dramatic expansion. Apparently, from the latest studies, unless we find a way to move to another habitable planet, we and the vast majority of complex living species will be doomed to be wiped out within a billion years. In fact, the latest evolutionary theories indicate that every 100 million years, the energy radiated by the Sun increases by 1%. At that rate, in a billion years, the Earth's temperature will reach prohibitive levels for life in general. For more complex and larger life forms, however, conditions will become unsuitable long before that. In about a billion years, the heat flux from the Sun will be such that the average temperature of planet Earth will exceed 45 degrees Celsius, as opposed to 15 degrees Celsius today. And rising temperatures interacting with the biosphere will compromise much of the plant life, breaking the food chain, such that the most complex and largest animals, including humans, will have great difficulty adapting as early as 500 million years from now. In short, even in the absence of other catastrophes or external interference, in half a billion years, life forms such as ours would no longer find a suitable environment to sustain themselves. Life, but in smaller and simpler forms, would probably continue in the deep sea and in small colonies on land. Will this then be our fate? In much less than a billion years of our civilization, will only those few individuals who have a chance to reach other worlds be saved? Would that we could get there, one would say, but a billion years is a frighteningly long time, and never has any species managed to preserve itself for so long. Try to think about it. There are currently only about 40 million animal and plant species on Earth. It is estimated that between 5 and 50 billion may have existed in the past ages. Therefore, only 1 in 1,000 still lives. The failure rate is 99.9%, a very poor survival record. The rule, then, is that species go extinct, and pretty quickly, too. One wonders, why have so many disappeared from the face of the Earth? Was it the fault of genes or bad luck? Were they less fit for survival or simply found themselves in the wrong place at the wrong time? Or perhaps a mix of the two? don't know yet. We can only say that no species formed by complex organisms has ever managed to last for more than a fraction of the history of life on Earth. In fact, according to biologists, the average lifespan of a species generally does not exceed 4 million years, which may seem like a lot, but it still represents 1 part per thousand of the elapsed time since the beginning of the appearance of life on Earth. Species with small populations are obviously the most prone to decimation, while those with widespread populations are the most difficult to eliminate. Among living species, humans deserve a separate discussion. While other animals are at the mercy of chance and natural accidents, with no possibility of control or defense, ours can predict happenings and correct mistakes. It may be, therefore, that with a little attention, we will be able to outlast 4 million years. After all, mankind has survived mammoths, malaria, plague, and atomic bombs. Nothing has killed us yet, and in short, one would almost come to be optimistic. But then, getting back down to Earth, there is to admit that from a few million years to a billion years, there is quite a difference. Is there really anyone among you convinced that in a billion years we will still be here, looking and feeling the same as we do now, still human? I don't think so at all. Not at least because a species can disappear in at least 2 ways. The first is a sudden environmental change triggered by cosmic catastrophes, asteroid and comet impacts, slow changes in Earth's orbit, global ice ages, etc. The second is that of its slow transformation into something else. If we succeed with our technology in escaping the worst disasters, certainly it will not be Homo sapiens with today's features that will do so, but a possibly entirely different species drawn by evolutionary processes that we cannot even imagine now. And when the time comes on the outer planets of the solar system or those belonging to other stars, creatures will find an escape that will be far more different from us than we are from our ape-like ancestors. In short, we will eventually disappear anyway, whether through cosmic catastrophes or slow biological changes, but not in a billion years. Maybe it will take only 1 million years to transform our DNA into that of another species. But what if, before that date, we are destined to measure ourselves against something truly destructive? Well, I personally do not believe that an asteroidal impact, a nuclear war, or a pandemic could wipe out the human species in its entirety. Always there will be survivors, capable of starting over, perhaps by trying to be smarter, wiser, kinder, more caring, and luckier than we have ever had to be before.